If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip.
The question we're working on today is, sketch the graph of the following quadratic function. And the function is y equals the quantity x minus 5 times the quantity x plus 1 plus 8.
Smash that like button and let's get started.
So we want to graph the function y equals x minus 5 times x plus 1 plus 8. And so the first thing we should do is get it into our standard form. So let's multiply out that product. So we have y equals x squared minus 4x minus 5 plus 8, and then let's combine like terms. So y equals x squared minus 4x plus 3. And there's a variety of things we need. So first, note that a is positive. So our parabola is going to open upwards. And our vertex will be a minimum. Well, let's find the vertex. The x component, or the x coordinate of the vertex, is x equals negative b over 2a. So that's negative 4 over 2 times 1, which is 2. Substitute that in for x to find the y component of the vertex. So 2 squared minus 4 times 2 plus 3. And that's negative 1. So our vertex is the point 2, negative 1. The axis of symmetry, this is really easy to find once we found the vertex. It's just the vertical line that goes through the vertex. So that's x equals 2. Now we want to find the x-intercepts. So what we do is we take our function, we set it equal to 0. So x squared minus 4x plus 3 equals 0. We could use the quadratic formula, or we could factor. It turns out factoring is not that bad here. So it's x minus 3 times x minus 1 is equal to 0. So that tells us that x is equal to 3 or x is equal to 1, right? Because we have the product of two things give us 0, so one of them is 0. So our x-intercepts are 3, 0, and 1, 0. And to get the y-intercept, we just substitute in x equals 0 and solve. It's just going to be the constant term from our function. So the y-intercept is 0, 3. So now, here's the coordinate plane. Let's just plug in all of our points, draw them all in. So there's 2, negative 1. There's our x-intercepts. And make sure we label all of our points. And then the y-intercept, 0, 3. So let's connect the bottom. And now what we should realize is we have an axis of symmetry. So the point 4, 3 should also be on our graph. It's the mirror reflection of the y-intercept. So we connect the dots, draw arrows to show it goes on forever, but that's really it. This is a rough sketch of the parabola.
Make sure to subscribe for more coffee and math with Dr. Weselcouch. Don't text and drive. Bye-bye.